Here is a result that should not happen. GitHub took Copilot Code Review, the agent that reads your pull requests, and swapped its old custom tools for a newer, better-maintained, shared set. Reviews got more expensive, and the agent caught fewer real issues. Better tools, worse product. The fix was not rolling back, and it was not a bigger model. Engineers rewrote the instructions around the tools, and that alone flipped the regression into roughly 20% lower average review cost, with review quality intact. GitHub published the full engineering story today, and if you build with AI agents, it deserves 10 minutes of your attention, because the failure mode they hit is probably sitting in your agent stack right now. Let me walk you through what happened. First, the setup. When Copilot Code Review looks at a pull request, it does not just read the diff. It explores the surrounding code to decide which problems are real. For that, it had its own exploration tools: list directory, search file, search directory, and read code. These were built for earlier models, which made fewer tool calls and were worse at pulling in context on their own. So when the tools searched a directory or read a code range, they could bundle in extra surrounding code automatically. Meanwhile, GitHub's Copilot CLI runs a leaner, shared, Unix-inspired set, grep, glob, and view, and a growing family of Copilot products runs on that same harness. Consolidating was textbook good engineering: one implementation, one place to improve, and every product inherits the gains. On paper, the migration was a simple swap. In offline benchmarks, the swap went backwards. Average review cost went up, and the number of useful review comments went down. Now, this is where most teams would stare at an aggregate score and start guessing. GitHub's internal benchmarks recorded something more useful: the full path the agent took. Every tool call, how much output came back, where errors happened, and whether the agent was narrowing toward evidence or widening its search. And the traces showed a clear pattern. The agent had stopped investigating the pull request and started browsing the repository. It searched broadly, guessed likely file paths, read whatever it found, discovered more things to search, and carried all of that along with it. Here is that loop. Simplified, the agent starts from the diff, but instead of asking a precise question, it widens a broad search, a guessed path, a big read, and every round makes the next round worse. Why worse? Because of a mechanic that is easy to forget. A tool result is not a disposable printout. For an agent, it is extra tokens that stay in the context window, where they can be carried forward into later reasoning. Irrelevant file contents do not just waste one call. They raise the cost of what follows, and sometimes make the review less focused on the actual question. If you have ever watched an agent session get slower and less sharp as it goes, this is usually the mechanism. The engineer behind the write-up, Napalis Klesius, contrasts this with how he reviews a pull request himself. He starts from the diff and asks targeted questions. Where is this function called? Is this config key used anywhere else? What is the smallest nearby code range that explains this behavior? A human reviewer wants the minimal context that answers the question, not a tour of the repository. The agent, with its new tools, was doing the opposite. Quick pause here, because I am curious and I do read the comments. When your agents explore a codebase, do you constrain how they search or let them roam? Tell me below. Your answer to that question is exactly what this story is about. So why did the agent behave like a browser and not a reviewer? Because nothing was wrong with the tools. The instructions were the problem. Grep, glob, and view arrived with instructions tuned for the Copilot CLI, where they came from. And in the CLI, broad exploration is often correct. A developer asks the assistant to understand a repository, plan a change, edit files, and keep going over many turns. A coding assistant may map an entire area before touching it, to be sure a change does not break some far corner of the code. Code review is a narrower job. Start from the diff, gather just enough evidence to decide whether the change introduces a real issue, and refuse to load anything else. Same tools, different job, and the instructions were teaching the wrong job. The fix was to rewrite the tool instructions around a reviewer's actual workflow, start from the diff, and form specific review questions. When the file path is uncertain, use glob. Use grep to find candidate files, symbols, and call sites. Batch the cheap discovery searches together before opening anything. And only call view, the expensive read, once you know exactly which file and which line range you need. GitHub describes the shift in rhythm this way. The old behavior was browse, read, search again. The new behavior is ask, narrow, read, decide. The wording changes were small. The effect was not. Take the concrete case from the post. The diff changes an authorization helper, the function that decides whether an operation is allowed. The wrong question is, show me the full contents of every file that calls this helper. The review-shaped question is narrower. Are any request handling callers relying on the old behavior? Grep for the callers, glob for likely handler files, view just the relevant caller ranges, and decide. 5 steps, anchored to the diff. The instructions also changed how the agent recovers when a search fails. After a failed grep, the better next step is one simpler, corrected search. After a wrong path, it is a glob lookup, not a round of guessing neighboring paths and reading whatever happens to exist. Small failures stop snowballing into exploration loops. Here is the part one would put on a poster. GitHub used its benchmarks to debug behavior, not just scores. Run the same review examples, compare the tool traces, adjust the instructions, run again. Did the agent narrow before it read? Did it batch independent searches? Did it call view only when it had a reason? And the most useful signal was not a vibe that the instructions felt better. It was concrete. The agent made a similar number of tool calls as before, but spent more of them on relevant evidence instead of repeatedly expanding the search. Same budget, better allocation. That is what connected a product metric to an engineering behavior you can actually reason about. The production result: roughly 20% lower average review cost compared with the control group, with no quality signal that could block shipping. 2 honest caveats, because that is how we do things here. These are GitHub's internal measurements. The post publishes no sample sizes, no confidence intervals, and no definition of the quality signals, so treat the numbers directional rather than audited. And no model names are given anywhere. This story is about the harness, not the model. But the direction is the point. None of the gain came from swapping tools or upgrading models. All of it came from changing the words that tell the agent how to use the tools it already had. Now the guardrail, and to me, the most valuable finding in the post. GitHub tried applying the same focused, review-style instructions back in the Copilot CLI. It did not produce the same kind of win, because in the CLI, exploration often is the job. There may be no single diff to anchor on, the user changes direction across turns, and the right context is not obvious at the start. The same grep, glob, and view can serve both products, but the workflow around them has to match the product. So the lesson is not that narrow instructions are better. The lesson is that shared tools scale when the instructions and the benchmarks match the job. Copying a winning prompt across surfaces is exactly how this regression happens in reverse. So here are the 3 things to take away. 1. A tool result is context. Every result your agent pulls back is tokens that stay in the window, so undirected exploration compounds. It costs you twice, in dollars and in attention. 2. Tool descriptions and system instructions are API documentation for your model. Unclear docs produce inefficient developers, and unclear instructions produce inefficient agents. A small wording change can move cost and quality more than a tool swap. 3. Debug traces, not scores, and match instructions and benchmarks to the job, because what wins in one product surface can lose in another. GitHub proved both directions of that. If you are building agents and this reframes something for you, subscribe. I cover engineering stories like this as they land. See you in the next one.